Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm really sorry, because of the delay. There is a heavy traffic jam just now. I'm not sure whether it is due to the accident or whatever reason, but it took like jam for like 3 kilometers, something like that. Okay, anyway, for today, we will continue the I think okay. So yesterday, we basically looking into this example, right? So for today, we will look into the next example, almost similar, but this one, we are working on a slender pole, okay, uniform slender pole. What does it mean by uniform? Uniform means the shape is the same from from the bottom until up here, and the mass distribution is also the same lah. Okay, that's why we call it the uniform slender pole. And this pole here has a mass of 100 kg if the coefficient of static and kinetic friction between the end of the pole and the surface are given 0.3 and 0.25 for the kinetic. We need to determine the pole angular acceleration at the instant 400 Newton horizontal force when this 400 Newton horizontal force is applied. Okay, so we need to determine the angular acceleration. And we know that this particular pole is originally at rest. Okay, it is not moving. So on this side, we can see we have a what we call it a free body diagram, right? And down here you have a to show that the things is moving down here. Okay. And if we look into the equation of motion, we can see that in the x direction, you have 400 Newton to the right. Okay, that's why it is a positive value. And then you have friction, or we can call it a friction, okay, a friction force to the left, and that's why we put it minus sign here, and all that equal to 100 kg times Ag, because we know that it is moving to the right hand side, right? And for this vertical direction, or in the y direction, we have an A, a normal force at point A, and then we have the weight of this particular pole, which is 100 kg multiplied by 9.81. Okay, and that is equal to 0, because this particular pole is just moving in the x-axis. Okay, no motion in the y direction, so it becomes 0 on the right hand side. And if we look into the summation of moment at point G is actually the center of gravity of this particular slender pole. Okay, and that is equal to Ig alpha. Okay, I is basically the moment of inertia of this particular pole. Okay, now, so what do we have? Okay, this is our G, and we know that clockwise motion is our positive direction. Okay, remember, clockwise motion is your positive direction. And we have FA down here. So FA multiplied by this particular length, 1.5 meter, because this is the what we call it normally moment arm. Okay, from the force acting to the center of rotation lah, in this case, G. And then minus 400 times 1 meter. Okay, 400 coming from this external force. Okay, 400 Newton. This horizontal force. Minus because of, if you apply this 400 Newton, this particular pole tends to rotate in the counterclockwise direction. So that's why you have a minus sign. And then no need to include this weight and the normal force, because they are both acting in the direction towards the center of the center of gravity. Okay, so no, you don't need to include this because there is no moment arm. Okay, on the right hand side, you need to calculate the moment of inertia of this particular slender pole, which is 1/12 times 100 times 3. 3 is the total length, and then you square it. Okay, and from here you have how many unknowns that you have right now? You have FA, AG, NA, and also alpha. So basically you have 4 unknown. Okay, and therefore you need another set of equation. Okay, otherwise you cannot solve this problem. So the first condition, we look into this no slipping condition. With this assumption, point A acts as a pivot. Okay, this is your pivot point lah. So that alpha is clockwise. Okay, meaning that this thing is moving in the clockwise direction lah. And AG is directed to the right. So AG is equal to alpha R. Okay, A is equal to alpha R. Remember yesterday I have shown you on the whiteboard, omega equal to V equal to R omega, and A is equal to R alpha or A alpha. It's the same thing lah. Okay, AG is equal to R. We know that the R is actually 1.5 meter times alpha. So since we have this set of equation, therefore you can solve for an AFA, AG, and alpha. Okay, again, we need to check whether our assumption is correct or not. Okay, the assumption, okay, we in this case, we assume that there is no slipping, right? But we need to check. The assumption of no slipping requires FA must be less, okay, less than mu, the static friction multiplied by the normal force at point A. Must be meaning that the friction at this point A must be greater than the FA. However, when we calculate, we found out that FA is bigger, and therefore we know that the pole is slip. Okay, because of this particular value is less than 300, right? So pole is slip. So in this case, we need to do the calculation for slipping condition. Okay. Since we know that this equation number 4 is not applied because our assumption right now is not valid anymore because of FA is greater than mu S times NA. So we need to use this particular equation, FA equal to mu K times NA. Okay. So mu K is given as 0.25 and NA is, okay, you have this equation. So combine this equation number 5 with equation number 1, 2, and 3. And therefore you can solve this NAFAAG alpha. Okay, so everything can be solved. Okay, this is the last example for this one. After this, I will go through the solution for test number 1. Okay, we have a uniform 50 kg bar, okay, and it is held in equilibrium position by chord AC and chord BD. Okay, we need to determine the tension in BD, okay, and the angular acceleration of the bar. Angular acceleration at any point on the bar will be the same, remember? Immediately after AC is cut, okay, you grab a scissor and then you cut it here. So what happened? That is what we want to analyze here. Okay, the first thing is to look into this free body diagram. What do we have when we cut this AC? So no more string, no more attachment at this point. So it is gone now. So what you have is you have a tension at point B, TB, and then you have a weight of this particular uniform bar, right? At point G, of course, at the center, because it is uniform anyway. And down here, there is another representation of what's going on during this process. Okay, let's go on this one. Summation of force in the x direction, we don't have anything, okay, in the x direction, so that everything here becomes 0 basically. So we only have forces in the y direction or in the vertical direction, and also we do have acceleration in the y direction, okay, AGY. So to solve this, first we have a TB. TB is pointing upward, so it is positive, and it is 50 times 9.81. It is nothing but it is your weight, W. And all those equal to minus 50 times AGY. Okay, 50 minus, because of the direction is of this acceleration is downwards. That is why it is negative sign. And then we took the summation of moment at point G, and we assume that counterclockwise is our positive direction. And then we have TB times the moment arm, which is 1.5 meter. And you don't need to include this W because it is pointing to this center of mass, right, CG. And on the right hand side, it is equal to I alpha. So I, again, 1/12 times the mass, and then time the R square. R square in this case is 3 meter from A to B, and multiply by alpha. So now you have two set of equation, and you also have 3 unknowns, which is AG in the y direction, TB, as well as alpha. Okay, we look into the kinematics part of it. Since the bar is at rest just after the cable is cut, then its angular velocity and the velocity of point B at this instant are equal to 0. Okay, because this is your initial condition. Okay, thus ABN is equal to, remember last time we learned about the normal acceleration, which is equal to V square over rho. Okay, I hope you still remember on that part. Therefore, AB only has a tangential component, which is directed along the x-axis. Applying the relative acceleration equation to point G and B. So we have AG is equal to AB plus alpha cross product with the RG with respect to point B minus omega square times RG with respect to B. So since you know everything here, then you can insert all the values. Okay, AG, you only have the AG in the y direction, and AB, I, and alpha K, and so on. So you are dealing with this set of equation. Equating the I and J, so you have something like this. Okay, sometimes you can also ignore this part, okay, to make it much more simpler. You can jump to this point. Okay, it depends lah. Okay, you can either proceed from here, and then you can just proceed to this part, which is A equal to R alpha, because you know R is actually 1.5 in this case. After you know all this, then you can solve for alpha, TB, and AG in the y direction. That's all. Okay, that is done. Can you turn on your camera, please, for a while, before we proceed to the next part? Wah, ada dalam komuter ni, nak pergi mana ni?
On the way balik.
Tak balik lah. How about the rest? Can you turn on your camera, please? Anbu, Reshikan, susah nak sebut ni. Reshikan, okay. Nurul Iza Izati. Siapa tak mandi lagi ni?
Ya, doktor, sorry.
Okay. Semua muka blur-blur lagi Okay. Don't forget to put your metric number in the chat section. Okay, we proceed to the next part, which is the solution. Just a second. Okay, after this, after I share the solution, that's the end of our class for today, but you still need to check the Putra Blast, because I'm going to put the link for some other videos. Okay. Okay. Let's move on to the first question. Okay, on this first question, we have a model rocket weighing, the weight is 75 gram, is launched vertically from rest at time t0 with a constant thrust of 4 Newton for 1 second. And then after 1 second, it is launched, the thrust, no more thrust actually, okay, after 1 second. It's similar like you riding a bike, okay, you cycling, and at some point after, let's say 5 seconds or 10 seconds, then you stop your cycling, right? And the bike will still go forward. Am I right? So the same analogy applied here. So in this particular problem, you can neglect the air resistance and the decrease in mass of the rocket. Okay. Of course, when comes to the actual physical condition, when this is launch of a rocket, then you are going to deal with the aerodynamic drag, okay, because there is a air trying to push you on the opposite direction. And also, since the rocket is burning some fuel, okay, burning some mixture of the rocket motor, then the mass will decrease. But in this problem, we ignore it. Okay, we neglect those effects. Okay, the first part, basically you need to draw the free body diagram, and then you need to calculate the velocity and acceleration of the rocket at time t equal to 1 second. Next, I'm sorry, there is a problem during this, I think during the printing, I believe, the A, you see, it is not correct in this part. And for B here, determine the time required to reach maximum height. C, determine the maximum height reached by the rocket. And D, assuming air resistance exists, explain how this affects the maximum height attained by the rocket. So the answer would be, first you need to draw the free body diagram for that particular rocket. You can use whatever shape that you like. Okay, in this case, I put a triangle. Okay, it is much easier for me to draw it. Okay, given the mass of the rocket is 75 gram and the thrust is 4 Newton and there is no air resistance. Okay, moving to this right hand side here, but you can see there are 3 stages. Okay, on the ground, I I put it at point 1 and then point 2. What is point 2? Point 2 is after 1 second, because you know that after 1 second there is no more thrust coming from the rocket, right? So starting from point 2 up until point 3, there is no thrust available. So that's why I put this 1, 2, and 3 steps. Okay, first, of course, you need to calculate the weight of the rocket, and then look into the summation of forces in the y direction, where we have T minus thrust minus weight equal to MAY. And then you rearrange that and you can calculate AY equal to 43.523. Okay. And then you can use this equation. Okay, you need to derive on this. A equal to dv dt, and you do this a bit of derivation. Then you can get this AYT equal to V2 minus V1. And then rearrange that, become this equation. And then you can insert the value of t, which is equal to 1 second from 0.1 until 0.2. That's why I put t subscript 1, 2. Okay, V2 is equal to 43.523 meter per second. The value is the same because the t is equal to 1 second. If t is not equal to 1, then you will have a different value for this one. Okay, this is just coincidence because t equal to 1 second. Okay, next. The next is to calculate this total time needed, right? So total time needed. First, you have to calculate the v at here, and here, 0.3 and 0.2. So we know that at maximum height, when the rocket reach to 0.3, V3 is equal to 0 lah. Okay, that's why V3 equal to 0. And what you left with you is V2 minus G T23. Okay, so T23, since you know V2, you already calculate here, right? V2, this is your, sorry, this is your V2. So you put it here and divide by 9.81. So you know your time is 4.437 seconds. So the total time is basically you need to add the 1 second from 0.1 to 0.2. And therefore you got 5.437 seconds. And then you want to calculate the total height. Total height, first you need to calculate from 0.1 until 0.2. So you can use this equation or you can derive it. Okay. So at this V1 is 0. So this whole part here is become 0. And this one here, you just plug in all the values and you know that at this particular point, the height is, okay, at this point, the height is 21.76 meter. Okay, and then from 0.2 up until 0.3, okay, from here 0.2 until 0.3, what's the height? So you can calculate that. We know that at V2, okay, and you know that the time from you know the velocity at this particular point, and you know the time from this point until this point up here. So you can then calculate all that. And that is equal to 96.55 meter. Okay, don't be confused. Huh? I think some of you might confuse because to calculate this one, this first part, you use AY. AY in this case is 43.523. Okay, this is your AY. And on the second part, because we don't have any more acceleration from the rocket, what we have is only the gravity, right? So that's why here you use a minus 9.81 lah. Okay, you put minus in the front here. Okay, and then since you know the height from here to from 0.1 to 0.2 and also 0.2 to 0.3, then you add them together and you get about 118.3 meter. And the last question is asked about the if there is a air resistance. Okay, okay. If the air resistance exists, it will act as an additional force, which is opposing the motion. And therefore, if you have a resistance, it will affect the maximum height. So your maximum height might be lower or reduced. Okay. For question number 2, okay, for this one, I think we have discussed this the day before the test, actually. Quite similar problem. Okay, we have point P on the cable has a velocity Vp 12 meter per second, which is increasing at a rate of 6 meter per second square. The mass of block A is 50 kg. So the first one, to draw the free body diagram, and then to calculate the acceleration of block A, and then to derive an equation of motion and determine the tension on the cable. Next is to determine the power output and the power input to the motor when the efficiency is given at 0.8. Okay, last one, you need to have a little bit of discussion. Because the motor is unable to provide the same amount of power output, due to some technical reason, its efficiency is reduced. Okay. Now, E is less than 0.8 lah in this case. If the velocity and acceleration of block A are to be maintained. So basically, the value E is no longer 0.8. It will be less than this. But at the same time, you want to maintain the velocity and acceleration of block A of this one. What changes to the power input are required in this situation? Okay, let's move on to the first part. I have meeting at 10, sorry. I have to do it very fast right now. I hope you can follow me. Okay, first you need to draw the free body diagram. I don't think I have to explain on this part. It is pretty much straightforward, right? And the next part is to calculate this. The acceleration, of course, you can refer to this one. 2SA, you have 1, 2 here, plus SP, this part, and equal to L. And then you differentiate to get the velocity, and then differentiate again to get the acceleration. And then you just substitute all the values to get the value of AA. That is 3 meters per second. And then calculate the summation of forces in the y direction. Okay, this solution is actually from the book, but there is a problem where summation of forces, not TA, is supposed to be 2TA. 2TA, sepatutnya ada nombor 2 depan. Okay, dan when you solve this, TA is actually 320 and, okay, 325, sorry, 320.25, the answer. This one I didn't update. I have another set of solution hard copy with me. So this one I haven't update. Okay, this answer should be 320.25. Okay, so after you got this value 320.25, then you substitute here. So you no need to divide by 2 here. Okay, don't have to divide by 2. TA just multiply by 12. Okay, because the velocity is given. The velocity of that block A is given 12 meters per second. So just multiply to get this value. And then to calculate the power input, basically you rearrange the equation for efficiency. Then after you calculate, you get 4.8 kilowatt. And the last one, what happens if you want to maintain the acceleration and the velocity of block A if the efficiency is reduced? So what you need to do is to increase the input power. Okay. Okay. Block A move to the right with okay. Question number 3. Block A move to the right with an initial speed of 3 meters per second on the inclined surface. Attached to the block B with rope. The mass of block A is 10 kg and the mass of block B is twice of the mass of block A. Okay, don't be confused. I just want to treat you. Block A is I draw it bigger, and block B is I make it smaller. But if you read it carefully, block B is heavier than block A. Okay, sometimes there is a trick on the pictures. So the first one, you need to draw the free body diagram, determine the tension on the rope, and to determine the velocity. And then what would happen to the speed of block A and block B if the kinetic friction is negligible? So what happened to the speed of block A and block B if there is no friction at all? Okay. And then what would happen to the tension on the rope if the inclined angle at block A is reduced to half? So right now you have 30 degrees. So let's say it become 15. So what happened? So first you need to draw the free body diagram. And then using this set of equation, right? And then oh, sorry. Okay, in this set of equation we have MA, BA. This is a moment equation, right? Then this is the external force, FA X, and I just put the FAX, but you can put anything you like lah. Okay, this one is represented by T minus WA sine theta, okay, and also mu K NA, okay, the kinetic energy. And on the right hand side you have 10 multiplied by VA2. After you solve this, you can print screen on this one. I don't have much time. I have another meeting after this. After you solve this part, therefore you can calculate and get the value of T, which is equal to 134.4 Newton. And then from equation number 3 here, you can calculate the VB2, which is equal to 8.76 meter per second. So, and in this problem, it asks what will happen in block A, block B if no friction. So what happens is that if there is no friction, the speed of A and B will increase. No energy loss due to friction or no resistance. And what happened again is the tension. If let's say the angle is reduced to 15 degrees, what will happen is the tension in the rope is increased. Okay, for question number 4, we have a mass. We have a ball that has a mass of 30 kg, and the speed is actually at 4 meters per second at this instant, as it is at its lowest point when theta equal to 0. So when the ball is here, speed is 4 meters per second. And in this case, we neglect the size of the ball, so there is no aerodynamic things involved in this problem. First, you need to calculate. You need to draw the free body diagram, derive the equation of motion based on the kinematic of particle, obtain a function to show correlation between the speed of the ball and the angle, and then determine the speed of the ball, the tension in the cord, and the rate at which the ball speed is decreasing. And lastly, to suppose the mass of the ball is increased, what would be the changes to the speed of the ball and the tension in the cord T? Okay, this is the solution. This is the free body diagram for that particular problem. So we analyze it using this normal and tangential force. So the normal force is given here. We have this T, and then we have this coming from the weight cosine theta, and then equal to 30 times this one is actually AN, which is V over rho. Rho in this case is 4 lah. 30 is the weight, the 30 kg of this particular ball. And for the tangential force, you have minus 30 times the minus weight sine theta, that is equal to 30 times AT. And from here, you can solve for AT, which is minus 9.81 sine theta. So you have two set of equation lah. And then you can start from this expression up here, and A ds equal to V ds, and since you know that the ds equal to 4 d theta, then you can replace all this lah. Okay, ds equal to 4 d theta. So ds here you replace by for the theta, and then you rearrange everything here to solve for this set of equation. And at theta equal to 20 degrees, then you can calculate for VAT as well as the tension on the cord. So the last part, suppose the mass of the ball is increased, what would be the changes to the speed of the ball and tension in the cord? So what will happen? The speed of the ball and tension in the cord will increase because of the momentum is increased. Okay, the last question. I only have about 2 to 3 minutes left. Okay, figure 5, depict an electric motor winch crate. The power input to the motor is 2.5 horsepower. The coefficient of kinetic friction between the crate and the plane is 0.2. Okay. First, you need to draw the free body diagram, derive the equation of motion. From the power input and the efficiency of the motor, derive the correlation for power output. And based on the kinematics, you need to derive the correlation for the speed of the crate. And then determine the tension, acceleration, and velocity after 15 seconds if the motor operates with efficiency of 0.8. And lastly, suppose the kinetic friction between the crate and the plane is neglected, what would be the changes to the tension in the cord, acceleration, and velocity of the crate? So this is the solution. First, you need to calculate the summation of force in the vertical axis or in the y direction, and then the summation of force in the x direction. And then you can get these two set of, the first one, you can solve for the value of N, which is 200 pounds. And the next part, you can have one equation, which is to relate between the tension and the value of A, the acceleration. So here you know that the power input is given 2.5 horsepower. You need to convert this into foot-pound per second. Okay, this process must be done. Okay, otherwise you are not doing it correctly lah, because you need to convert this unit first by multiplying 550. Then you can then calculate for the power output. Okay, just multiply this value, power input, with the efficiency, which is 0.8. Then you get the power out is equal to 1,100 foot-pound per second. And that is equal to T times the V. For the kinematics, the speed of the crate is, you can derive it like this. So V is equal to 15A because V0 is 0. It start from rest, right? And after you substitute equation number 3, okay, this one, you substitute into this equation. Then you can get this equation number 4. Okay, once you get this equation number 4, you can put it in the first equation up here. Okay, because this T is equal, right? The same T. So you can substitute that. Then you can solve for the value of A, the acceleration of this particular crate. And after you have calculate the acceleration of the crate, then it is much easier for you to determine the, but by looking into this equation number 3, you can calculate the velocity of the crate at this particular instant, and also the tension on the crate. Okay, you can use equation number 4 if you want. Okay. Okay, the last part asks about the, if the tension is if the kinetic friction is neglected, what will happen? the tension in the cord will be reduced. Okay, if there is no tension, then you may need less effort, right? So tension is less, and the velocity and acceleration are both increased. So when there is no resistance, of course, it will move faster. Okay, that's all from me. Keep update on the Putra Blast, and I will let you know through WhatsApp once I have successfully upload this link on the Putra Blast for the videos. Okay, thank you very much. Do you have any questions so far?
No, doctor.
No. Okay, I'm sorry. Yeah, I'm a little bit late, but I'm forcing myself to stop right now because I have another meeting, and I'm supposed to be punctual, but yeah, things happen with that is outside of my control. Okay, Assalamualaikum warahmatullahi wabarakatuh. Have a good weekend. And I know that next week is a school holiday, but not a holiday for you. That is only for the student at school, not student at UPN. Okay, bye-bye.
Bye, doctor. Assalamualaikum.
Thank you, Dr.
Um,
Thank you, doctor.
Doctor.
yes.
Doctor, this video will be uploaded in Putra Blast also, the recording on this one.
Oh, yeah. Okay, I'll try. Yeah. Okay, thank you.
Okay,
Yeah.
thank you, doctor.
Yeah.